Alright guys, good afternoon. So we are done actually with solving quadratics. We are going to move on to a little separate topic that it sort of goes along with quadratics, and you'll see it again later on in the year. But we're going to talk about complex numbers today. So when you think about what the word complex means, usually we think complex means hard, okay? In this case, these are not going to be very hard. Here's what complex numbers do mean. They mean I've got a real part of the number and I've got an imaginary part of the number, which kind of makes sense why you might call it complex, all right? If you can't tell the difference between what's real and what's imaginary, life gets a little difficult. So when it asks you for a definition here, a complex number is written in the form, it looks something like this, A plus BI. Okay? And A and B could be any number. So some examples, you could have 3 plus 4i. You could have 5 minus 4i. All of those would be complex numbers. A, or the number that's by itself, is the real part, and BI, so whatever the number is that's with I, is the imaginary part. Okay. So for example, if I had the complex number 4 plus 5i, 4 would be the real part, 5i would be the imaginary part, okay? So don't let that terminology trip you up. Now, we have talked about I before, and it's been a little while, so you may not remember this. But I is just kind of a abbreviation we use, or a letter we use, to stand for the square root of -1, okay? People didn't like having to write the square root of -1 every single time, so they just called it I instead. Well, what that means is that I squared is something that's actually a lot simpler. So if you take the square root of -1 and you square it, what happens? Well, that square root and that square, they cancel each other. And all you have left is -1. So since I is the square root of -1, if I take I and square it, all I'm left with is -1. And that is going to be very, very important when we start multiplying imaginary numbers together, okay? So make sure you got that written down. Now, there are lots of different things that I can do with complex numbers. I can add them, subtract them, I can multiply and divide them. So we're going to talk about just a few of those things today. The first one, you may not know you know how to do it, but you really do. All that you have to do when you're adding and subtracting is combine like terms. So for example, in part A, 7 and -11 are like terms. Well, if I put those together, 7 minus 11 gives me -4. Then I do exactly the same thing with the imaginary numbers. I have a 3i and a positive 10i. Well, if I put those together, that gives me a positive 13i. And I'm done. There's nothing else to do. I know that looks really simple, and it is, because it's simple. It's not complex. Okay? That's your answer. When you get to part B, it's almost that simple. The only thing that's different in part B is if you notice, first of all, there are parentheses, and there's a minus sign between those parentheses. What they want me to do is, since that minus is sitting right next to the parentheses, they want me to take it and distribute it. So I haven't changed anything about the 8 plus 4i. That's going to stay exactly the same. What is going to change is I'm going to take this negative and distribute it inside my parentheses. So now instead of having a positive 13, I have a negative 13. Now instead of having a negative 7i, I have a positive 7i. Okay? And at that point, I'm doing exactly what I did in example A. I'm putting my like terms together. So 8 minus 13, those go together. 8 minus 13 is -5. Then I put my i's together. 4i plus 7i becomes 11i. And there is absolutely nothing else I can do to that. I'm done right there, and that's my answer. Okay? When you look at part C, it is going to take you a little longer. It's not super difficult. But anytime I have parentheses and they're sitting right next to each other, so notice the difference here. In example B, there was a minus sign between those parentheses. Here there's not. There's nothing between them. that means they want me to multiply. And you may have heard a word here before, FOIL. If you remember how to FOIL, that's exactly what we're doing. But another word for FOIL is just distribute. So what I'm doing is, first off, I'm taking the -5 and distributing it times everything in the other parentheses. So let's do that first. -5 times 6 is -30. And -5 times -3i. Watch how I write this. -5 times -3 is a positive 15. And I'm just going to tack the I onto the end. It just kind of sits there. There's nothing else I can do with it. Okay? Then I do the second part of my multiplication. Now I take the 2i and distribute it times everything in the other parentheses. So 2i times 6. 2 times 6 is 12. And then the I just gets tacked on to the end there. At the very end here, here's the term that trips people up. I have 2i times -3i. Well, 2 times -3, that's -6. I times I, that is not 2i, that is I squared. Okay? So here's the first thing you should notice. First of all, I've got two like terms here. I can take 15i and 12i and go ahead and squish those together in the middle to make 27i. The other thing that you might remember that we wrote down towards the beginning of these notes was that I squared was equal to something. I squared is equal to -1. So what I can do now is I can erase I squared and replace it with -1. Okay, so here's what's happened here. I don't have -6 times I squared now. I have -6 times -1. Well, what that does is it changes my signs. That turns that into a positive 6. And now I have two like terms that I can put together. I have a -30 and a positive 6. Well, when I put those together, that gives me -24. And then you're done. So a couple things to remember about multiplication. Make sure you're distributing, okay? Don't just take -5 times 6 and 2i times 3i. You should have 4 numbers when you first multiply these together, okay? The other thing to remember, if you ever get I squared, you've got to go back and replace that with -1 because I squared equals -1. So let's do one more example, part D, and it does look a little different. If you ever see something to the second power, what that means is they want you to write it twice. So what I actually have here is 1 minus 4i times 1 minus 4i. Well, now I'm doing exactly what I did in part C. I'm distributing. So first of all, I take 1 times everything in the other parentheses. So 1 times 1 is 1, and 1 times -4i is -4i. Then I distribute again. I take the -4i times everything in the other parentheses. So -4i times 1 is -4i. -4i times -4i, and let's break this down. -4 times -4 is a positive 16. That hasn't changed. I times I is I squared. So at this point, there's a couple things that we need to simplify. First of all, right in the middle here, -4i and -4i. Those are like terms that I can put together. They make -8i. The other thing that I can simplify is I know that I squared happens to be -1. So I'm going to replace it with -1. So now I say, okay, what is 16 times -1? Well, that's -16. And my very last step, I now have two like terms that I can put together. 1 and -16. Well, 1 minus 16 gives me a negative 15 minus 8i. And then you're done right there. So go ahead, get started on your activity for today. Something that I do want you to note, if you look at the instructions for today's lesson, you are working on a coloring activity. You are only doing the circled problems. So do not feel like you have to get them all done today because you don't know how to do all of them just yet. So happy coloring.